The study of natural duality theory has revolutionized our understanding of algebraic structures, particularly in the realm of Unary Algebras. At its core, this theory provides a method for translating difficult problems in one class of mathematical structures into easier ones in another class. This transformation is not merely a computational convenience, it offers profound insights into the underlying symmetries and properties of these structures. The text under discussion delves deeply into this area, focusing on the concept of dualisability, specifically within the context of Unary Algebras. Dualisability, in essence, refers to a finite algebra's ability to create a natural duality. This property is not only a theoretical curiosity, but also a powerful tool for understanding complex algebraic systems. The book provides an in-depth exploration of this topic, highlighting both its theoretical underpinnings and practical application. The journey into the theory of natural dualities begins with the concept of quasivarieties. Quasivarieties are fundamental in universal algebra, providing a framework for describing and classifying algebra. In this part, we explore the definition and properties of quasivarieties, focusing on finite Unary algebras. A quasivariety is defined as the class of all algebras that satisfy a set of quasi-equations, logical statements involving terms and variables. For a finite Unary algebra, its quasivariety, QM, is described by several equivalent descriptions: as homomorphic images, subalgebras, and products, as satisfying the cancellative law for semigroups, or as satisfying a set of law quasi-equations. The ISP theorem further enriches our understanding by equating these descriptions with the ability to separate algebras by homomorphisms into M-O. One of the most striking examples of dualisability in Unary Algebras is the small algebra QL, whose quasivariety, ISPQ, is equivalent to the category of all Q-graphs. This example not only illustrates the complexity of dualisability, but also highlights its potential as a source of examples and counterexamples for further research. The introduction to natural dualities in Unary Algebra sets the stage for exploring more advanced topics, such as strong dualisability and full duality.
In this section, we delve deeper into the construction of natural dualities for Unary Algebras. The concept of duality is central to this exploration, and the text provides a systematic approach to establishing dualities between an algebra and its quasivariety. We begin by considering a finite Unary algebra, M, and its alter ego, M, all G, G, Q, at, where G, H, and R represent sets of operations, partial operations, and relations on M. The text presents a construction that yields a duality between an algebra and its quasivariety. For each algebra, a Yokwani in the category ISBM, the topological quasivariety consisting of all isomorphic copies of topologically closed substructures of non-zero powers of ME, its dual, day, is defined as the closed substructure of MM, formed by the set AAM. Similarly, for each structure, XE in ISCPM, the category of topological structures, its dual, XS, is defined as the subalgebra of OMM, formed by the set ETANS, MAM. The authors then introduce two functors, PA, D, A, TOX, and UL, E, X, 2A, which map an algebra to its dual, DA, and a structure to its dual, DEX, AL. These functors are crucial for establishing the duality between the category of algebras, ISP, and the category of topological structures, ISCPM. The duality compactness theorem further reinforces this relationship by asserting that if OMM is a finite algebra and its alter ego, MLGGQPH is a finite type, then M yields a duality on ISPM. The preservation lemma and independence theorem are also introduced in this section. The preservation lemma ensures that certain properties of algebras are preserved under the construction of dualities, while the independence theorem provides a condition under which an algebra's dualisability can be deduced from the dualisability of another algebra. Strong dualisability is a more stringent condition than simple dualisability, requiring that the duality not only exists, but also satisfies additional criteria. This part of the text explores the concept of strong dualisability, which ensures that a finite algebra can create a natural duality that is a special kind of dual category equivalence. The strong dualisability problem and its corresponding decidability problem remain unsolved within the class of dualisable algebras. The authors provide numerous examples and techniques for creating both dualizable and non-dualizable Unary algebras. One notable example is the construction of an algebra with three elements that is dualizable, but not strongly dualizable, as demonstrated by Heinemann and Willard. This discovery underscores the potential for finding pathological examples in duality theory. The text also introduces techniques for constructing algebras with specific properties, such as having enough algebraic operations or being quasi-injective. These techniques are used to build examples that answer long-standing questions in duality theory, providing a deeper understanding of the complexities involved. The complexity of dualisability among Unary algebras is a recurring theme throughout the text. The authors highlight the potential for finding counterexamples and pathologies within this class, which adds to its richness as a source of examples and counterexamples. One such example is the algebra QL, whose quasivariety, whose ICPQ, is equivalent to the category of all Q graphs. The text also explores the relationship between dualisability and other properties of algebras, such as separability. The authors provide a toolkit of results that serve as fundamental tools for exploring these properties. These include the duality compactness theorem, the preservation lemma, and the independence theorem. Another key concept explored in this section is the notion of strong idempotents. Strong idempotents are elements of an algebra that satisfy certain conditions under a binary homomorphism. The authors establish a lemma and a theorem related to strong idempotents, which provide valuable insights into the structure of dualizable algebras. The final part of the text discusses the applications and future directions of natural duality theory. The authors emphasize that dualizability is not just a theoretical curiosity, but has practical implications in various fields, including computer science and artificial intelligence. By leveraging the symmetries uncovered through duality theory, researchers can design more efficient algorithms for data processing and analysis. The text concludes by acknowledging the contributions of many researchers who have worked on natural dualities in Unary Algebras. Their work has laid the foundation for further research and provided valuable insights into the properties of natural dualities. The authors also discuss ongoing challenges and open problems in the field, encouraging future exploration.
In conclusion, this text provides a comprehensive treatment of natural duality theory, focusing on developments that have occurred since Clark and Davies' foundational work. The exploration of dualisability in Unary algebras not only deepens our understanding of algebraic structures, but also offers